Hello. How is everyone? Okay. So yeah, this workshop. What's the title? It's like building 4G sites and playing with them, basically. Well, I'll let you deal with it.
Yeah, am I live?
So yeah, you are live, kind of. So so this is James Bodie. Who doesn't know James Bodie?
There's some of you I haven't met before.
There's like 2 people that don't know James. So James does a load of cell site stuff, and he's got
crazy stuff.
And he's got some awesome new venture going on in the UK, which I guess he'll talk about a bit. So and then you get to play with some sims that were all in your bedrooms, but we've probably got some spares somewhere if you have forgotten them. Cool. I'll hand it over to James, and have a fun couple of hours.
Thanks. You, Dan. Well, hello everybody, and not there's any competition between this stream and the other stream, but there may be a small wager running on who has the most people and the most interactive crew. So it must be pointed out that Tim Panton is cheating because he's got an internet babe. Can I say that? Into his session just to get his numbers up. But anyway, so what I'm going to show you today is how you can deploy your own 4G mobile network. And you go, ooh, that's difficult, isn't it? Can I do that? Is it legal? Where do I get all the bits from? Well, hopefully I'm going to answer all those questions. But you've got to go through some kind of boring bits. So why am I so enthusiastic about LTE and 5G? Isn't Wi-Fi good enough? Well, the answer is no, it's not. 4G and 5G are much, much better than Wi-Fi in terms of performance. What you can actually get through on a little bit of spectrum, you'll get a lot more through using an LTE or 5G waveform. And there are other tricks you can do. And I just remembered I've missed out a slide, which is explaining 5G with my left-hand and right-hand rule. But hopefully I can remember to put that in. But the question is, how can people who are not a mobile network operator deploy and manage LTE that real people can use? So somebody who walks in off the street with their phone in their pocket, how can you do that? Well, hopefully I have the answer. So my objective, our objective, my team's objective is to make setting up and using a private LTE network as easy as deploying a Wi-Fi access point. Wow, that's a biggie. In order to do that, we've set up something that we think is a bit new. We're going to call it a PNO, not a MNO, mobile network operator, but we're going to call ourselves a PNO, a private network operator, or private network enabler, which enables other people to set up their own private networks. But these are private networks that become part of the public switch telephone network. Okay, a little bit of boring stuff we have to go through just to bring people up to speed and work out where everything fits in. Very quick potted history of the evolution of mobile. 2G, 2.5G, quite old. 1991, the first bits and pieces appeared. And interestingly enough, there was GSM before there was GSM, except it wasn't called GSM. It was called a UK military project called Ptarmigan. And it entered service in the British Army the same time as me. And it left service the same time as me. And by the time I spent 22 years in the British Army, I'd gone from being a little baby officer up into being the technical authority for this thing called Ptarmigan. But anyway, that's a previous life. You don't want to know about that. 200 kilohertz waveforms, giving how many channels is that? 30 channels? It's 32 channels plus 1 for framing, 1 for signaling. Using narrowband voice, using adaptive multi-rate codec, which isn't half bad actually, but it's a bit narrowband. And it's got a little bit better. So first of all, when it first arrived, it really didn't do data at all, other than sort of circuit switched, 14K4 type data, not particularly good. But then we got, in 2000, GPRS, and I remember actually being on the GPRS trials for Orange in UK. It was part of my job to be part of that. Anyway, then it got a little bit better, a bit faster with Edge, enhanced data rates for GSM. And they used SIMs. These were actually SIM cards, but, and these were actually cards, but later SIMs became software only. But more of that later. Used A5 encryption. Signaling behind it is the indomitable and quite antiquated now SS7, which signaling scheme number 7. Mean anything to anybody? Yeah, a few people. Yeah, it's been around for a long time, totally insecure, and 2G widely acknowledged as being hackable today. And in fact, later in the week, one of those two cells at the back, we're going to, both of them are currently set up for 4G, we're going to reflash one back to 2G in order to demonstrate how we can capture all your phones and your traffic as well. Ooh. So that'll be fun. Anyway, a little bit later, 3G arrived, and 3G was all about let's do data as well as voice. The first release 99, did a massive 384 kilobit per second, absolutely smoking hot, if you'd only seen Edge before. But then that rapidly evolved into something a bit faster with HSPA 7.2 megabit per second, and then whoa, red hot HSDPA up to 21 megabit per second. Now we're really cooking, we thought. But it still uses a good old SS7, all kinds of security issues there. Some new bits and pieces came in there. Improved authentication. One of the problems with 2G was it doesn't authenticate the network back. So if you're a bad boy, then you can pretend to be a network, and because the system doesn't authenticate in both directions, then you can get up to all kinds of naughtiness. And all of a sudden, they decided to make encryption mandatory, which was great. I didn't mention one of the issues with 2G is that you can turn the encryption off. So if you're weebling around in the Ukraine and all of a sudden you find that your phone's in 2G and the encryption's turned off, you can bet your bottom dollar that all your traffic's going through Moscow or something like that. But 4G, 4.5G. This is LTE. Arrived around 2011. Lot faster. We can do up to 300 megabit per second. And in fact, that's what my team are going to be using in our rural demo, 300 megabit per second waveform, if you've got a lot of spectrum. The advanced spec agreed 2011, deployed 2013, which just goes faster. It's available in 2 flavors. There's FDD, which is what we normally see around here, frequency division duplex. That's where you have a transmit frequency and a receive frequency, lower, okay? 2 frequencies. But there's also another flavor called time division duplex. And with TDD, you use 1 frequency, but you just ping pong on 1 frequency. And that's what we're using today for our demo. We're using TDD in band 40, which is 2.3 gigahertz. Various bandwidths you can use. The narrowest one, 1.4 megahertz. I don't think anybody uses 1.4 megahertz because it's pretty crappy, really. I know a few people who are using 3.3, but normally it's 5, 10, or 15. We're using 20 because we've got lots of spectrum. But more of that later. The voice element is no longer circuit switched with LTE. It's all IP based. So VoLTE, voice over LTE, is the mechanism. Also note that with 4G, particularly with the early runouts, they had something called circuit switch fallback, which, because some network operators found it a bit tricky to do VoLTE because it was new, they just fell back to circuit switch on 2G or 3G. So if you hear that. And then there's a pro version which just goes even faster. And the whole thing is tied to 3GPP releases. So 3GPP is the body that sets the standards for mobile. And a whole load of different people work together to come up with these releases. And we're now, this is where we are at the moment, release 15, which has defined all the 5G stuff. But there's some really very interesting stuff in there. This is probably a good time for me to actually talk about what 5G is. I haven't got a slide for that. No, I don't think I have. So, everybody thinks that 5G is all about going even faster. But there's more to it than that. Because 5G is probably the most exciting and cleverest evolutionary stage we've had so far. Well, it definitely is. Because not only is it capable of going faster, but it operates in 2 other dimensions. So remember, I said that with 5G there are 3 dimensions. They are speed, latency, and power or range. And normally you can't have all 3 of those at the same time. So if you want to go really fast, then it takes quite a lot of power. But, and normally, if you want to go really fast, then because you're increasing your packet size, then your latency goes up as well. But there are a number of applications like flying drones or telemedicine and things like that. You want really low latency. And so to do that, normally you just reduce the size of your packets and put headers on so that the low latency stuff goes to the front of the queue every time. And then the third axis, I think, is probably the most interesting one, which is all to do with power. So with these very, very clever waveforms, you can operate at very, very, very low powers. But why would you want to do that? Well, the answer is you might want to build an IoT device with a built-in battery that lasts for 10 years and costs $5. And with that sort of kit, the most expensive component is actually the battery. And it costs far too much to replace the battery, so you just make it last for 10 years. So example use case would be something like an oil tank or something like that, which reports once a day or something like that. So three axes: power, speed, and latency. And they tend to be mutually exclusive. But depending on what your use case is, that's what you do. So I went off-piste a bit there, didn't I? Drivers for change. Why can we even contemplate now running private networks? Well, a whole load of things have changed. One of them is this, software-based networks. Going back a couple of years ago, if you wanted to set up a mobile network, you had to invest in lots of big, expensive grey boxes that would sit in a colo from somebody like Nokia or Ericsson or even Huawei if you're hard up. And whatever you buy, the box price is normally about 100 to 150K per box. And that's the going rate. And you just need lots of them. But why don't we do all the stuff that those grey boxes do in the cloud? And that dramatically reduces the cost. Also means that you can deploy this stuff much quicker. It also means you can make it massively scalable. And it develops quicker. And of course, we've got our good old friend open source. Is Daniel here? Yes, there he is. This man here is responsible for Kamailio. Kamailio is possibly the most dynamic, wonderful building block for building mobile networks. But more of that later. In fact, yes, I'll say that again. Kamailio is a wonderful tool for building mobile networks. There we go. We got that one. But then you can't read the word. Anyway, just keep pressing the button, because the good stuff is later on. Another thing that's really changed, or changing at the moment, is spectrum. Up until very recently, the only people who could get spectrum are the big mobile network operators, who tend to pay billions for big chunks of spectrum. And when they've got it, nobody else can use that spectrum. That's a bit of a problem if you want to set up your own network. But things are changing. So in the States, we've seen the introduction of something called LSA, License Shared Access, or the American title for this is CBRS, Citizens Broadband Radio Service. Nothing to do with CB, because it's up at 3.4 gigs. It's a bit like DHCP, but for spectrum. So you get a cell, you put it out there, press the go button. First thing it does, scans the band, listens for anything that's going on there, and then reports what it can see and where it is and its operating parameters, things like power and antenna gains, back to a central server. And based upon what's reported and what it's got in its database, the central server then issues a lease back to the cell for a chunk of spectrum. So it's a bit like, just like DHCP, but for spectrum. And there are 3 tiers in LSA. Top tier is government. So if government needs the spectrum, you know, US Department of Defense, who incidentally use that band for radar on aircraft carriers. So if there's an aircraft carrier steaming down the coast and it's got its radar on, they'll get the spectrum first. Then there's a tier below that, which is the paid tier. So if you want spectrum and it's mission critical to you, you pay money to the regulator and you get a higher priority. But then you've got the bottom tier, which is free, that anybody can use. And because there's quite a lot of this spectrum, it means that just about in every scenario, if you want spectrum, you'll get it, and it'll be free. So brilliant. So US have got shared spectrum already. But the problem is it's up at 3.4 gigs, and how many handsets work at 3.4? Well, there's one. And it's that new, I can't remember what it's called now. Anyway, see me afterwards if you want to know what that is. So that's one way of getting spectrum. Oh, and in Europe, we're going to get LSA, but it's going to be called DSA. And there are only going to be 2 tiers, which is the paid tier and the private tier, but more of that later. Another way of getting spectrum is this one, which is the way that my team are doing it. Secondary use on a non-interference basis. So if you can convince the regulator to do this, you can get a license, a secondary license, to use primary spectrum, but on a non-interference basis, on the basis that it's not being already used. Works particularly well when your mission is to fill not spots. So if there's a gap in coverage, there's no coverage there, by definition, the spectrum's not being used. So you get secondary use on a non-interference basis. And by the way, the form of words is important because there's legal and procedural things tied up with that. License-free operation. Yeah, we're getting LTE in license-free spectrum, specifically the top end of the 5 gig band. So where some of this point-to-point Wi-Fi lives at the moment, you put LTE in there. Incidentally, if there was a boxing match between LTE and Wi-Fi, who do you think would win? The answer, it's LTE every time. It's a much more aggressive waveform. It just take down the LTE. So what Multifier does is they put a Wi-Fi sense preamble on the waveform, so that if there's Wi-Fi, it just backs off a bit and lets the Wi-Fi do a bit without totally massacring it. So, but believe me, Wi-Fi is nowhere near. It's a wimpy waveform. Forget it. Ugh. Use LTE. It's much cooler. And if you have to, you can always go to operators, and you can either lease spectrum from them or do a deal, a quid pro quo deal. But that's the one that I don't like because it involves MNOs. It's hard work. Yeah, and there are formulas that you can run to work out the cost of spectrum. Normally it's on a megahertz / pop, number of population you cover within the area that you want the spectrum. So more people that live there, the higher the price. More spectrum that you use, the higher the price. Shared access. So The center of the system for license shared access is a thing called the SAS, the Spectrum Access System. And I've already told you how this works. I'm not pressing this button fast enough, but that's what it is. The cells report their location, operating parameters, what they can hear, and then the SAS does its DHCP thing and gives you a lump of spectrum, typically on a 2, 3, 4, 5 day lease. If you live out in the middle of Montana or something like that, you'll get like a 3-month lease because nothing ever goes on there. Now, this is the slide that makes your eyes bleed, because it's got some really good, interesting stuff. This is what's going on in Spectrum today. Certainly here in UK. So DECT band. When GSM first started, there was concern that GSM and DECT cordless phones would interfere with each other. So the regulators put a 3.5 meg. It's actually 3.3, isn't it? No, 3.5. They put a guard band in between the two. Later, they discovered it was not a problem. So this chunk of spectrum at the top end of the 1800 GSM band became available for low power use. And you know what? We're using it right now, legally. The constraint here in UK is that you can only run a maximum of 300 milliwatts output power. But that's good enough for in-building. So we're using it. We've got that. Oh, and it's lightly licensed in UK and license-free in Netherlands. And watch this space because it's going to become license-free in UK as well. Yeehaw! We like that one. By the end of the year. But don't quote me on it. Sub-licensed LTE is what we're using in the countryside for our little LTE pilot program, something called Chalk Mobile, but more of that later. And we've actually got all of the 800 megahertz band, all 2 times 30 megahertz. And the excuse for that is if we have all of the band, then it allows us a little bit of wiggle room to deal with interference at the edges. But what it means is in the middle of the network, we can go really, really fast. Incredibly fast, because we've got more spectrum than the MNOs. And believe it or not, Ofcom said yes to it. But, or subject to consultation with the MNOs. But they're not fighting, amazingly, because they've got a problem doing covering rural areas. But more of that later. TDD bands. All of these TDD bands. Band 40, which is the one we're using here. Band 42, band 43. Well, you can read what it says there. This one here, band 40, is particularly interesting because half of it has been released for auction here in UK. But guess who's got the other half? 2300? Anybody guess? Who's got the other half of the 2300 band? No, radio amateurs. Yeah. So, yeah, spot on. Apart from, you're a radio amateur? Yeah. Well, we ended up in Chicago a couple of years ago at the TAPA DCC. TAPA is a Tucson Amateur Packet Radio Group. They're really hardcore techie radio hams. And I ended up, by mistake, giving a presentation on how radio hams should be running TDD LTE. And nobody threw things at me, and I was amazed. So actually, I think it's quite feasible. The only tricky bit is radio amateurs are not allowed to encrypt communication. But the way you get around that is you just make all the keys 0 and publicly known keys, and it's not encrypted anymore, is it? Well, that's my argument anyway. So this one here, license-free, multi-fire. That's particularly interesting because it's license-free and anybody can use it. Particularly useful for in-building, where you want to just cover in-building. And with SDR radios, of course, you can combine both Wi-Fi and LTE in one box with one antenna because they're the same band. Yeah, shared with Wi-Fi, but yeah, we know about that. And then we've got 700 megahertz coming with the close down of terrestrial analog TV. So that's coming as well. And that's really, really useful spectrum. Anyway, press the button quickly. Whew. Spectrum. Identity and authentication. The subscriber identity module, or SIM. Now with 2G, the little plastic cardy thing was the SIM, but with 3G onwards, it's not anymore. Why is that? It's because the SIM is just software. The actual hardware now is something called a UICC, which is a Universal Integrated Circuit Card. Yeah, it's just the hardware, but the SIM is actually software, which is a combination of both data registers and code. So I bet you didn't know that your SIM in your phone has got a processor, a memory, and it's got a secret covert back channel, encrypted back channel, that the operator can talk to. I bet you never knew that. Yeah, you can run applications on your SIM card independent of your handset. Well, you can't, but operators can. I can. It's huge amounts of fun. So these are the sort of things that your SIM will have. It'll have an ICC or UICC ID. That's the number which is engraved on the front of it. That's how you identify it. But the bit that is really, really important is this thing called the IMSI, the International Mobile Subscriber Identity. Now, normally a SIM card will only have one of those. But if you're an interesting sort of chap, you'll have a multi-IMSI SIM card. But more of that later. It also has authentication keys, a whole raft of them, of which possibly the most important is the KI, which is unique to the IMSI. It comes as a pair. And it's how that IMSI authenticates itself in order to join a network. Clearly, if you're going to have multiple IMSIs, you might want multiple sets of crypto as well, but maybe not, I don't know. It has a whole load of other stuff, which is fine, yeah. Okay, yeah, I mentioned this. So normally SIMs only have one IMSI and one set of associated cryptographic key variables, but more sophisticated SIMs, such as these from Truphone, who you may recognize the name. There were 5 of us when we started it. We got up to 1,200 strong, and then the Russians arrived, and we ended up being owned by Messrs. Abramovich and Abramov. But it cost them about 740 million. But we got diluted out of it, and we left. So, yeah. So these are the ones that we made for Truphone. They were multi-IMSI. This particular one only had one set of crypto because it only ever authenticated back with Truphone. But if you want to authenticate with multiple places, or clearly if you want to run your own authentication system, you want your own crypto, don't you? So multi-crypto could be really good. So the scenario is when you're on your home system, you authenticate with your home HSS or HLR, and then you walk out through the door and go out of range, and then you switch your IMSI to attach to the public network, and you authenticate, and you need a different set of crypto. And at any one time with a multi-IMSI SIM card, only one IMSI is active at once, and that's how you attach to the network. And the reason you want multiple ones is that it just allows you to attach to the network in a slightly better way. Then you can have multiple user profiles, and it's this thing about imps and impus. You know, anybody know about an imps and impus? So you only have one impu, but it can have multiple imps, and those are identities. And they can be either a SIP URI or a TEL URI in 3G, 4G, 5G IMS speak. Yeah, so you can have multiple phone numbers all active at the same time. And yeah, the multi-IMSI thing is a bit like, you remember James Bond had an Aston Martin DB4 with a rotating number plate. And the idea behind that was he drives it across an international border, presses the button, it goes boop, and he's local because he has a local number plate. He goes into another country, press, boop, and he's local again. Cool. Well, we're like that with SIM cards, with multiple IMSI. Yeah. So this is one of our, in fact, it's a black one. If you ever see a black SIM, get rid of it as quickly as you can, because normally the first ones we ever make of a batch are black ones, which means they normally go wrong. So just a random kind of thing. So this is a black MONeH SIM, first generation. It was rubbish. It certainly did go wrong, but we're up to third generation dark blue now. Third generation ones are good. And the special event one that we cut especially for ComCom is a third generation one. So these are pretty cool. They don't go wrong. It's really embarrassing when you give out SIMs and they don't work. So these ones are multi-IMSI, multi-crypto. Yeah, it does all of that. As I mentioned, the signaling channel is always on and it's always free. Anybody flown cross transatlantic on Virgin Atlantic? Yeah? Yeah, because they have onboard GSM, don't they? Hours of fun if you have your own SIM card and you control the crypto and the bits the other end. You can have hours of fun with it. Because the signaling channel is always open and always free. You know, it's a bit like, do you remember, are you all old enough to remember ISDN, where 2B plus D channel, and people used to, rather than have to pay for the phone call, ISDN call, to get their email, they just pushed email down the D channel. Well, it's kind of like that, but mobile, because the signaling channel is always open because it has to be. And it's always free because there's no tariffing on it. So if you've got your own SIM card, you can get at that signaling channel and do. You can get about 300 bits per second through it. It's not super fast, but it's good enough to do text messaging and things like that. Yeah, other things that you can do. Things like, how about running a web browser on your SIM card? You've already got a computer on there where you can do that. And that's all in the SIM spec. And then there's a whole load of different apps you can run on the SIM. It's got an ARM processor. It's got almost as much processing power as a first generation Pentium PC and can have considerably more memory. Just think about that. And where are you? There you are. You're going to talk about blockchain, aren't you?
Yep,
tomorrow. Good one to come and attend. Just a random thought. If you put blockchain on a SIM card to do the rating, billing, and settlement, what do the MNOs do? Because the only bit that they've got left is the rating and billing engine, and they throw out bills. So, yeah, not good if you're a mobile network operator. So let's talk about IMS. You keep on hearing this term IMS bandied about. What does it stand for? It stands for IP Multimedia System. So all of our digital devices now are going IP-based. There's no circuit-switched, phone call type stuff anymore. It's all IP-based. And 3GPP come up with lots of diagrams which look remarkably like that. They are scary, aren't they? They are brain damage. Until you realize that about 70% of that you can do with Kamailio. Yeah, one package does, and it just simplifies the whole thing. So yeah, that's the IMS subsystem. These are functional blocks. They don't have to be boxes. They're just software processors. Just use Kamailio, it's easier. So IMS basically has two protocols in there. There's SIP, which we know, being VoIP geeks, we know SIP pretty well. And Daniel knows it even better because he's Mr. SIP. But the other one is diameter. And diameter, you're going to say, is that related to radius? And yeah, and it is. It was based on radius, but it's got better. In fact, it's more than twice better. So that does all the signaling bits that used to be done by crappy old SS7 map, but in a somewhat more secure way. And the feature set is richer. So when SS7 map was put together, the handsets were pretty primitive, so they couldn't do very much. But they've got a lot smarter since, And so there's a whole load of really useful stuff that you can get your fingers into with diameter, which you can do base apps on, things like that. So that's all IMS is. It's SIP and diameter. So if you know SIP, and we have lots of SIP gods, I've just noticed who's in the audience, yeah. Then you're fine. But there are frictions, things that will try and stop you from becoming a mobile network operator. And this is one of them. Okay? The whole organization is really designed to make it incredibly difficult for new entrants to get into the feeding chain. If you're a member of the club already, you're fine. But otherwise, forget it. This particular document, the IR21, is particularly important. So the IR21 is how the GSMA police interconnect routing and settlement. Well, no, not settlement, that's something else. But if you want to become a mobile network operator, you really have to plug in with an IR21, because if you don't, then you don't communicate. And the only way to access to IR21s is, well, through a full member of the GSMA. The backdoor way is you work with somebody who already is a full member of the GSMA, and you put your numbers on their IR21. But unless you're a full member, you can't do it. And my colleague Callum is going to talk about that now. We're going to try something really quite interesting here, aren't we, Martin? Because we're going to be joined by my colleague, Callum White, who is in Glasgow, or just outside Glasgow at the moment.
Will we be able to understand it?
Well, I hope so. Is he not there? Andy, can you give him the number? And I'll pad a bit. So I told you this is dangerous. There's no safety net here at all. So I'll put up his slide. So he's going to talk about all the horrors of becoming a mobile network operator. Now, there are a number of people around here. I'm just looking to see if I can see Simon Woodhead, who wasted a huge amount of time and effort and energy trying to become a mobile network operator and didn't. Okay, so shall I just show you the whole point of having Callum here is that you don't have to listen to my voice droning on and on and on, because we decided that people might start getting suicidal before we get to the demo bit. So so after we've done this little bit, we'll talk about some use cases, and we'll talk about the demo specifically, and we'll talk about the SIM cards that you have got, and what they can do, because you have no idea what those little SIM cards are capable of. Now, have we a vote from the Glasgow? It's just like Eurovision Song Contest, this, isn't it? The Glasgow jury. Or is it going to be null point? Well. Okay, well, I'll tell you what, let's very quickly skip over his bits, and we'll come back to Callum later. So the dangerous demo. So we've been doing dangerous demos with GSM for some time, and it all kicked off following TAD Summit, TAD being the Telecom Application Developers Summit, run by Alan Quayle, that's him, from the Isle of Man. A lovely chap. It became apparent that in order to demo a lot of the TAD stuff, you actually had to have a mobile network. And so somebody said, I bet you can't build one. And I thought, and I love it when people say, bet you can't, because it makes you want to do it. So we did. And we fielded the first iteration in in Istanbul in 2014 thing. So it's a cooperation between Truphone, Canonical, the Ubuntu guys, Telestacks, and MetaSwitch. And it blew everybody away. Everybody thought it was amazing, apart from the two gentlemen from Ericsson sitting in the front row who thought it was really crap. Can't think why. So next year, 2015 in Lisbon, we added a whole load of apps sitting on top of it and demonstrated how scalable it was. We wanted to, what we were doing? Yeah, we were loading it up with voice calls, and the intent was to get it up to 100,000 concurrent calls before the end of the demo. And at the same time, we were demoing away whilst this thing was going, there's another processor, there's another one, there's another one, all done on Amazon. It was hairy old stuff. By the end of the demo, we got up to 86,000. We didn't make the 100,000, but it kind of proved the point, and it didn't crash. So that was great. 2016, we tried to be a little bit smart, and we added some first-generation radio access network stuff on the end. It totally crashed and burnt. It was awful. So 2017, last year, we tried to do the same thing again and got a lot closer, but it still wasn't perfect. But here, we've got it right, and it is now working. Yeah, this is what we did in 2017. The team members, note, by this time, we'd all left Truphone and become Telet Research, based in Northern Ireland, using Acceleran cells. In fact, here's one I prepared earlier. This is an Acceleran E1000, IP67 ruggedized cell of the type that you bolt to your chimney. I've got a little description of this later, so we'll see that again when we come to that. Summer Networks added the HSS, NG Voice, dear old Carsten Bock did the VoIP piece. And this is what we showed. Multi-operator neutral host operation. What multi-operator neutral host means that it's open to anybody who comes anywhere near it. And this is what we were demonstrating. The E1000s have got an 8-core Cavium processor in there and about, is it 64 gigs of RAM or something like that? Massive amount of memory, which means you can run all of this stuff on that at the edge. It's really, really cool. And what that means is that then it simplifies things in the back end. So you only have a much lighter core in the back end, which then interfaces out into the operators. And interestingly enough, it just simplifies things massively. So that's what we did. We had all those boxes at the front end. And this is Acceleran. Oops, if you hadn't seen them before. These units are about, the hardware's about 2 years old now. But they're not software-defined radios, these ones, which is why they come in different band variants. So you actually have to buy the box for the band, and you can't change it. Price for these is one-off. If you want to buy one, it's about €2.5 euros. Acceleran is Belgian. And the ones we're using here are TDD ones, so they have 2 antennas, so it's 2x2 MIMO, power over Ethernet up there, which does the backhaul and the power, and then a GPS on the top, because it needs to know where it is to report back for the CBRS, for the license share and access stuff. Also, if you've got a TDD one, it does timing. Yeah, the timing is critical if you're going to work with multiple ones, because if you get the timing wrong, it just doesn't work. Anyway, that's the E1000. Clonk. And that's what it does. What if I... GNSS is just GPS. Up to 64 concurrent active users and IP67. So typically you bolt that on the chimney. And it's got all of that. Yeah. And it does all of that as well. It's a very capable little box, shall we say. But this is the future. If you look towards the back of the room, you'll see there's a little white 3D printed box. Don't break it, Corey. So that does everything that that does and more. That is a software-defined radio. It's what we're working with at the moment. And that covers all bands up to 6 gigahertz. And that allows us to change the waveforms and protocols just by reflashing the software. So last week, that was a 2G box. We had to do a demo for a government minister. And the mission was that when he walked in through the door, his phone had to work. So we did it all on 2G because it's easy. But we thought, as we're coming here, we'll reflash it to 4G just to show off 4G. So it's operating 4G at the moment in DEC band, top end of 1800. If you do a quick scan on your phone, the little white cell is 23404. The acceleron is 23588. So you should be able to see both of them, as long as your phone supports the bands. Yeah, dramatically reduced cost, power, and size because it's a software-defined radio. And it can support multiple waveforms concurrently, as long as, bearing in mind, you've only got a limited amount of power. So if you're going to do 2 waveforms, then you have to split the power in two ways. But massively useful. So you can do 4G and 2G on the same box at the same time if you want, which is cool. This particular one is running narrowband LTE in the DEC band, top end of 1800. And later in the week, I mentioned it before, we're going to reflash that and have a go at all of your phones. You probably noticed you keep on, your phones keep on getting up a strange message saying that you're not authorized to do things. That's because as you maneuver around the room, you get into a not spot where it drops the external signal. Your handset then goes into search mode, looking for the strongest signal. That's it. It then tries to attach to it. And because we haven't set up the S6A diameter on the back end, it goes, no. And that's why you're getting that message. If we had the S6A running, then we'd authenticate back to your operator. And if we get the right crypto back, then you're in. Yeah, have you tried turning it on and off? Yeah, so that's exciting stuff. And here's one in operation. So I mentioned Chalk Mobile. This is one of those little white boxes on the end of the village hall in Bowerchalk. The antenna is about, 5 or 6 times bigger than the cell. So that's a 360-degree single sector antenna up above it. And the demo here is running. If you want to have a go, just pop the SIM in your phone and it will work. So that's a screenshot from the front of Randy Resnick's phone. Is Randy here? No. So if you're having problems, it'll be one of 2 things. One is the APN, which you need to put in its internet. The other reason will be because we had a screw up with putting the cryptographic key variables in the HSS. So if you take your SIM to Andy at the back, he will put it in and it'll work. So that's why, if it's not working, that's why it's not working. Yeah. Second demo, yeah. So that's what we're doing. And they're working. So it's almost worth a round of applause. Yeah, louder for Tim. Yeah. Anyway, he probably thinks I've finished now. So let's talk about the SIM that was in your room. This is the Aston Martin of the SIM world. I had to think of something that was really reasonably cool and something that's not owned by... In fact, is Aston Martin owned by the Germans now? Who owns Aston Martin? Is it still British?
It's Skoda, isn't it?
I hope not. So anyway, this thing has got, it's not your normal SIM. These SIMs cost $4 each to produce. That gives you an idea of how sophisticated they are. They have got a Samsung S3 FW9 F4 system on a chip, which includes an ARM processor. You're going to Googleize this afterwards and find out what you can do with this. It has flash memory, it has ROM, it has RAM, quite a lot of RAM in fact. It has special optimized, power optimized cryptographic hardware in there, and it's all bundled up in a package which is anti-tamper. So if you try and disassemble it, it wipes everything. How cool is that? And it's set up to run multiple IMSI and multi-crypto. Your next question is, how do I get the crypto into the SIM? Well, there are two ways of doing it. Either you can do remote update, which is over the air, and all the key variables required to do that were preloaded into the SIM. We haven't released the APIs for that yet, but we will. In the short term, the other way to do it is to use one of these. So this is a plug-in SIM card reader-writer. So just like you to have a little flash RAM drive to write an SD card, you can get these and plug your SIM in there. And with the right little bit of software for your Ubuntu or Mac, or dare I say it, does anybody use Microsoft here? Probably not. No. I don't believe it, Eric. So you can write, and with the admin variables which we give you, you can read some of the contents of the SIM as well. So that's one option. Another option is to use something like this. I bought this particular one off eBay. It cost £8.50, brand spanking new in the box, and it has a SIM smart card reader, which is jolly useful. And this is the Panzer of the keyboard. It's incredibly heavy. £8.50 on eBay, brand new in the box, bargain. So when you take your ComCom SIMs home, if you want to read and write, drop us a line and we'll ship you the APIs to do it. So not the APIs, the drivers to do it. So we're particularly interested to find people doing interesting things with those. Yeah, SIM applications. We haven't really talked about those. Those of you who know mobile and SIMs well will know that they... Stand still. Have you got Callum?
We have Callum. You'll have to tell him where you are and what to say.
Okay, all right. Can we have Callum up?
We can try. There's a possibility we won't be able to hear him. Just trying to test this.
Okay, let's see whether we can hear him. Callum, come in. Glasgow. Oh, there he is. Can you hear me?
Yes.
You can hear me? We can't hear you.
We can hear him here, but unfortunately it's not coming out of the speakers because there's some problem.
Right, Callum, you're going to have to cue your presentation in semaphore, okay? I know there's noise coming out from somewhere. Yeah, but very faintly. Say something, Callum.
Hello.
Yeah, there's a noise coming from behind the screen. A little faint.
That's the projector probably.
He's coming out of the projector. Right. In the meantime, Callum, can you see us? Have you got
Yes.
a wide shot of the room here?
Yep.
Yeah. Well, I can hear you here.
All
Say
right.
something.
As long as I holler loudly.
Yeah, there's a tiny little voice coming from back there somewhere. It's really quite bizarre.
I'm not that softly spoken.
Yeah, I can't hear you. Yeah, but anyway. Yeah. We need somebody to do lip reading and, you know, simultaneous. How are we doing for time? Gosh.
Still, in the meantime, while we're getting the audio working, can I ask a question?
Yeah, let's do a question. Have we got a mic? Or just shout. We got a mic.
Ask it, and then repeat it.
No, here comes there's a mic coming.
So how does the OTA work, and what channel does it go on?
Okay, how does the OTA work and what channel does it use is the question. So well, you do the channel bit first. It uses the GSM signaling channel. So remember the 200 to 300 bits per second, always on, always free channel. That's how it pushes stuff. And it encrypts using a special encryption key, which is built into the SIM. And there's a specialized server that pushes stuff into the SIMs. Does that answer your question?
So the MVNO or MVNE has to...
Yeah, use the microphone.
The MVNO or the MVNE has to provide access to that channel, right?
Well, in this scenario, we are the MVNE, so yes is the answer. So it's our SIM card, it's our server. We control both ends. And then the channel between is always free, always open, but we encrypt the channel.
So how does that work in like a roaming scenario?
Perfectly. Because the signaling is always on, it's always free.
Would you like to ask Callum just to speak and see if we can hear him?
Okay, Callum, would you say something?
Hello again.
No,
No,
nothing.
not yet.
We have, his audio is getting to us, but we're not there.
Well, can we give him a mic?
Yeah, let me see if I can bring something up.
Yeah,
Yeah, that's right. Yeah, that's a good idea.
well, we've done that before. Do you remember ClueCon last year? And Andy couldn't make it to ClueCon, so we had a robotic Andy running up and down the aisle, menacing people with a microphone on. And that worked, didn't it? Yeah, it's quite scary. Any more questions whilst we're... Yeah.
I want to know what MONeH is.
MONeH. MONeH stands for Multi-Operator Neutral Host.
Okay.
It's also, I'm told,
Say that term and read
yeah, ghetto slang for MONeH, isn't it?
Yeah,
As in, give me your MONeH. But yeah, we thought it was a good...
Neutral host meaning the network, rail network?
Neutral host means that it's a radio network that all operator SIMs can be used on. Clearly, our 4G network here is not currently fully MONeH. The reason for that is we have not engineered the S6A diameter link that goes from our core in the back end into diameter, DSX, the diameter switch exchange point.
And before we started the debugging of the video feed, the last thing that you said was you were going to tell us something about the SIM card and the software that runs on it, and you said those of you who are familiar with SIM cards, ...
Oh, SIM Toolkit. Yeah, I was going to talk very briefly about SIM Toolkit. SIM Toolkit is that little menu thing that you get up in SIM cards. So that is the 1990s vintage way that you interact today with your SIM card. Because when it came out, the phones were only capable of giving you about sort of 3 or 4 lines worth of text. So that was fine. But of course, things have moved on now. So a slightly more modern way of interacting with your SIM card would be to use something called SIM socket. It's not like a SIM socket is a thing that allows you to connect a web browser to your SIM card. And it's a bit like localhost on a PC. So you end up connecting to yourself, but in this case, it's the phone connecting to the SIM card. And so you can then have a web browser, which is can be a bit more feature-rich than 4 lines of text.
And Java card play a role at all? Or was that like...
Yeah, the Java card, well, that's the environment. So most of the code in fact, virtually all of the code on the SIM card is Java-based, just because that's how they did it. But you can have a huge amount of fun programming SIM cards. It's a difficult area to get into because unless you work for a SIM manufacturer, you would normally not do it. But once you get into it, you realize what you can do. In fact, here's a man who is a known abuser, just come in. Cesare, hiding behind the plant, is a known abuser of such things and doing things who once upon a time used to work at Truphone. Used to work for me, bizarrely enough. But he's kind of evolved since then. So, are you still there, Callum? No,
yes, I'm still here.
We're trying very hard. So, have I got any more slides? I've probably got some more. No, this is where we were going to bring in a remote person number 2, but Carsten can't make it because he's doing childcare. So pretend you're Carsten, and I'll just be Carsten's voice. Welcome, I am Carsten from Germany.
Yeah.
And I am going to tell you how wonderful Kamailio is as an IMS core. It is rock solid. Yeah, Carsten has been abusing Kamailio for years now. And I have to say that in the early days, his failure rate was quite high, wasn't it? He used to be a bit of a train wreck when it came to demos. But he persevered. He's totally German, very, very focused. And actually, he's got it all working. So he's now using Kamailio as IMS core and running VoIP as well. The original core that he used came out of the Fraunhofer Institute in Berlin, which is where Daniel studied. It's a little hotbed of IMSE type protocol-y stuff, and is also where Kamailio Worlds takes place every year. And if you haven't been there, you've got to go to Kamailio World just because of the people who go there. Yeah, it's all of those. Yeah, that's boring. These are Carsten slides. That's why they're black and white. Yeah, and it does all of that, actually. So originally, oh, look. Oh, you can't see the slides. Of course you can. There we go. Yeah, it does all of that. And in the old days, Kamailio was SIP only, but it's kind of grown. It now does diameter and a whole raft of other bits and pieces. It's worth mentioning that SMS in 4G and 5G tends to be SIP-based as well. So has anybody played with SIP Simple? It's not simple at all. It's quite complicated, but apart from Cesare, who's but yeah, of course, Daniel has. In fact, Daniel set up the Truphone SIP SMS in the old days. It took him about, well, 30 minutes or so. Absolutely amazing. But yeah, it uses SIP Simple, and it's not simple. And there are applications there as well. Oops, where are we going? And now there are a number of LTE mobile network operators around the world that actually use Kamailio. So the first ones were based on in Nigeria and Tanzania. Smile Telecom, South African. You know the boys from Smile Telecom, really good, really good. But since then there's been another one in Bulgaria and there's one in Belgium, isn't it? It's Belgium? I'm looking at you. We're not supposed to know where they are we? No. But anyway, they're springing up all over the place. So the great thing about Kamailio-based network operators is that they are low cost, but also extremely flexible. And so Carsten is claiming circa 200,000 subscribers, native VoLTE, with an OTT app in 3 continents. And loads of labs. If you want to run a VoLTE lab, just to find out how the thing works, Kamailio is a great bet. And he says, thank you very much. And so thank you, Carsten. Let's very rapidly run through the rest of these slides, because deployment cases. So the one that we're using as our justification to become a mobile network operator is this one, the Chalk Valley. It is the largest knot spot in the whole of the south of England. And guess who lives in the middle of it? It is me, yes. And it's even worse than that, because when I said we need to fix this, everybody thought it was such a good idea. I got voted to the council, and I'm now the chairman. So there's no escape. I have to fix it. So, so a knot spot is an area where there's no coverage. And not surprisingly, there are quite a few of those in UK. And they tend to be in the really rural, nice places where wealthy people, not that I'm wealthy, but people like to live there. And then there are partial knot spots, and that's a partial knot spot is an area where you've got one network operator, but the others have no coverage. Those are the thresholds for signal levels that you have to achieve to be deemed to have service. Note the difference in signal levels. So the bigger the negative number, the smaller the signal. So what does that tell us about 2G versus 5G? The answer is 5G is very much more capable than 2G.
Hello, folks.
Oh, Callum!
Yay!
Hey, can we go back to Callum, Martin? Hey, there he is. Right, do you want to introduce yourself and we'll do your slides?
Okay. So, my name's Callum White. I've been working with James for many years.
That's scary.
So I've lasted well. So my background is in telecoms, from manufacturing through to ops and maintenance, fixed networks, mobile networks.
In the last 10 years, I've been with
mobile networks and involved in number portability, sourcing number ranges, dealing with regulators, operators, all that fun stuff.
So all the fun stuff you've been doing then?
Yeah.
Yeah, lucky old you. So, are you going to tell us what makes an operator?
Okay, yeah. So, do you want to show the slides now?
Yeah, can we go back to the slide, Martin? So we're looking at what makes me a mobile network, sorry, what makes me a mobile operator? So do you want to talk through that? Oh dear. Yeah, come back, Callum. Oh no, you're back again now. Looks like we have to look at your face.
All right.
Well, just explain it. Just talk us through.
Okay. So operators are defined as parties that have spectrum and provide service to end users. Essentially, that's the definition. Separate to operators, we also have virtual operators, referred to as MVNOs. Commonly, these ride on the back of other networks. So if you look at organisations such as Virgin Mobile, the people that operate on T-Mobile, Tesco Mobile, I believe, are on the Vodafone network. But in the case of Research, we are an operator in our own right.
Yeah, that's us, by the way. We're Research, if I didn't explain that. Sorry.
Okay, so things that you have to consider is what services will you provide and how will you provide them. So standard stuff, mobile voice service, SMS, MNS, not many people do that anymore, and of course data. Sounds like the audio is disappearing. Oh.
Yeah, we can put up the slides now, Martin, apparently. Without losing Callum.
I'm still here.
Yeah, you're still here. I think this is great. I mean, no safety net at all. There we go.
Right, so
yeah, that
other
works.
things to consider are, will we deploy our own RAN, or will we partner with a network that already has a RAN deployed? So in the case of the project we're doing across the Chalk Valley, our options to deploy our own RAN. You then have to consider what elements do you need to provide the service. So do you need an IMS, DRA, SMSC, etc., etc. So figure out what your services are, and then what elements you need to deliver those.
Okay, next slide.
Yeah. So, things to consider. What do you need from the regulator? To be an operator, you've got to have a spectrum license. So, a few hoops to jump through here. So, you have to consider what frequency you want to use, what bandwidth, and the power level that you're going to transmit on. Is it a frequency that's available you're applying for? And then how long will it take to secure that frequency? So one of the things there is the frequency that you're wanting subject to auction? So you've all seen auctions in the UK for spectrum before, where
Spectrum have paid literally hundreds of millions to get the spectrum. Right, let's see what's next. So, number range. So, if you're going to be an operator in your own right, you're going to need to have a block of numbers. In addition to that, you'll need an operator code, you need a porting prefix. So, depending on the country you deploy in, you may need to support number portability from the outset.
Yeah, Callum, you make it sound so easy.
It takes a lot of effort and quite a bit of time.
We'll cover that towards the end.
Okay.
So when you're applying for your spectrum and for resources, there's a whole bunch of things you've got to put together to support your application, and this applies in pretty much any country that you want to deploy in. So your business registration details, obviously, give an explanation of your business, including the business case, and your estimated market and growth rate. So the regulators, they're interested in volumes, and they need to understand your volumes so they know the size of blocks, etc., to allocate to you.
Okay, next slide.
Yeah.
There you
go. Okay, so things from other operators.
This is the really tricky stuff, isn't it?
Yeah, this is the proper pain in the butt stuff. So, interworking agreements. So, first off, are you going to be delivering traffic direct to another network? If that's the case, then you will need an interworking agreement with that operator. Then, are you going to offer your mobile service in other areas that you don't geographically cover? So, if it's, as an example, Chalk Mobile in the Chalk Valley under Research, to give service to Chalk mobile subscribers outside of our coverage area in the UK, we would need some kind of roaming agreement with an operator that has national coverage. Similarly, if we wanted to offer service overseas, i.e. our users travelling abroad, then we'd have to partner with an international roaming partner. So there are a few out there that do this. So then the general traffic routing, connectivity with a national or international carrier. So traffic that you don't route direct to an operator you've got an interworking agreement with, you're going to have to route the traffic outside of your network somehow. So ET would be the obvious one, and there are others out there as well. Where are we now? Yeah, inbound traffic. So Chop Mobile will have a number range assigned to them.
So
So if there's subscribers with other networks, how does traffic from that network reach to a Chop Mobile user? So we've got to have an ingress route into our network. So again, that could be a two-way agreement with DT or someone. So in addition to using someone like DT, you could turn to a mobile operator and ask them to host your number range. That way the traffic would route via them and then be delivered by them into the network. So a few choices to make.
And then you've got the other fun stuff that you have to do as well.
Yeah. So registrations. So you've got people like the GSMA. Very key to get knowledge of your network out to the wider operator community. So you can publish your IR21 that contains all of your connectivity details via the GSMA.
Yeah, you've missed off the AA14 and the AA19 as well, which do tariffing, rating and tariffing, and that's a horrendous thing.
That's right. There's heaps of it. In addition to GSMA, there would be a number of portability organisations. And these exist in various countries. So you obviously register with the organisation relating to the country you're operating in. Then there are advisory bodies, forums that you need to join as well. So, for example, data protection. One that's hot in the UK is controlling access to restricted websites. So, yeah, an operator wouldn't want juvenile users, let's say, being able to browse to iffy websites using their handsets. So there's that type of thing goes on.
Yeah. Okay. Next slide.
Yeah.
Oh, and some more juicy stuff on here. Hours of fun to be had here.
We started off with it sounding so easy. Now, as we get further on, we're seeing all the gotchas. So, compliance responsibilities. Basically, got to support lawful interception, got to support emergency calling, data protection, we mentioned that previously, the shiny new GDPR, which I've typed wrongly here. We mentioned number portability as well. Commonly, you've got to support that before you're allowed to become operational. And then you have the challenges of IREG testing and TADIC testing. So IREG for international roaming and TADIC for the billing side.
Brilliant. Okay. There's a summary.
Yeah, so if we go on to the last slide.
That's the last one.
Yeah. So the challenges, timescales, dealing with regulatory bodies, something like this can take an eternity. So you're going to go through hoops to meet the application process. Then you'll be faced with consultations being performed and then waiting for feedback. So it can literally take months, getting on to a year, and even more in some cases, depending on the frequency that you apply for, especially if it comes within an auction scenario. Then dealing with the operators, when you're requesting interworking agreements with them, you've got to provide business justification to them. There's commercial agreements, and very frequently you've got security deposits. Obviously the operators want to protect any investment they make. because they're involved in project planning, equipment allocation, etc. on their side as well. Then you've got the planning route with the operators and fitting into timescales and their schedule as well. And then, of course, going through the testing phase. So lots to do in that front. And then moving on to the one that's most painful, particularly to me being Scottish, are the costs. Excuse me. So spectrum, as we know, can run to hundreds of millions. Then network build and implementation. So you've got the physical cost of the hardware, you've got the licensing, and then the implementation timescales. Depending how good you are, how many people you've got around, that can be a number of months to a couple of years, even longer if you're building a big run. Then another thing to consider is mobile numbers. We all see them as just an asset. But in the case of Australia, as an example, operators are actually charged an annual fee per individual mobile number that an operator has allocated to them. And then you have other things creeping in, such as membership fees, GSMA, and the various forums that you may join or be required to join as well. These all have operating costs, and frequently they're divided up between the membership.
Well, you ought to see people's faces here. They were excited, they're now a little bit less excited now, Callum. Thanks to that little summary.
I will offer an apology. This is the first time I've done something like this.
No, but it's okay. Because we've got some good news, haven't we? Because you don't have to go through all of that if you have the services of a PNO to do all of that for you. And yeah, we take the pain and you just plug in your cell. That's the message we're trying to get across, even though it's quite a painful message. But all of that Callum's just gone over is what you have to go through to become a mobile network operator. And it is painful. But once you're there, oh, there's so much you can do. Which is right, isn't it, Callum? I think.
That is very correct.
That's very correct. Right, thank you for that. Don't go away, because hopefully I want you on the panel at the end. But I've got to go get through a few slides first before we go on to the panel. So we'll go very quickly. Thank you, Carsten Bock. So we were just talking about the Chalk Valley. Can we go back to slides, please, Martin? But just hang around there, Callum, because we might need to. So we were looking at that one. So the Chalk Valley were due to receive coverage from a government project called the Mobile Infrastructure Project, and the plan was to put big masts. This is a 20-metre high one, but they go up to 30 metres as well, across the countryside. I'm going the wrong way. There we go. And this is the Chalk Valley along here, southwest of Salisbury. And 1, 2, 3, 4, 5 were to cover the valley, and I live just there. Needless to say, none of those turned up. And the minister responsible got the sack. There was a hanging party of about a dozen Tory backbenchers went and took him off at the knees at Westminster. His name was Ed Vaizey. You can watch it on UK Parliament Live TV. And there's a beautiful bit where he's asked to give way for about the 12th time. And he says, no, I will not give way. I'll answer this, make this point, and then I'll sit down and you can queue up and stick your daggers in me. And the camera cut to John Glenn, my MP, going. Shortly after that, Ed Vaizey was sacked and John Glenn became a junior minister in DCMS, the government department. Funny that, isn't it? But that's called politics. But John Glenn has now been promoted. He's now 2IC to the Chancellor of the Exchequer. So he's a flyer. But anyway, that's the ground. But instead of putting 5 big masts up, our plan is to deploy a number of smaller cells like this E1000. So between 50 and 70 to cover the ground. This is the village of Bowerchalk. I live just there, in fact. So this is a 500-meter radius. That's the radius of operation for one of these to go from chimney top to inside the house, taking into account the construction of the houses. Bearing in mind, my house is 440 years old. It's got walls about that thick. So about 500 meters range if you're inside. If you're outside, we're talking about 1.1, 1.2 kilometers. If you have a chimney-mounted antenna, out to about 3 kilometers you can be away from these. So in a village like Bowerchalk, you can cover all of the houses with 5 cells, but typically we put in 7 to allow a little bit of overkill, so that if somebody unplugs the cell to plug in the vacuum cleaner, it doesn't drop you out. So that's the plan with these cells. Other applications for this, and the great thing about the Chalk mobile thing is we've set up the operator as a community interest company, so owned by the local community, and they will operate the cells, but the deal is the government pay for the installation, the upfront cost. And the cost to put in between 50 and 70 cells is about a quarter of the cost of putting up those 5 MIP masts. A quarter of the cost, and it goes faster and better. The service will be multi-operator neutral host for all networks and fixed wireless broadband. Bearing in mind about 50% of the Chalk Valley has got really crappy broadband. So hugely popular. So no big masts in our area of outstanding natural beauty. Hurrah! If I don't get an OBE medal from the Queen for this. Which is important because my younger brother got an MBE, but that's another question. So another use case, underground networks, and I use Metro because that looks like London Underground, doesn't it? But I'm not allowed to say London Underground. So if you say Metro Underground, this will be a system which is owned by the operator. And why does the operator want to do this? Well, mainly because he doesn't want other mobile network operators down in his tunnels, because he owns all the cables and everything down in the tunnels. So the last thing he wants is Vodafone or O2 tramping down his tunnel, putting cells there. So he wants to run it himself. When it's down there, it would run multiple network slices. I don't know whether you've heard that term before, network slice. So it's a virtual service, but all on one infrastructure. So you'd have the general public having their normal phone call service, multi-operator neutral host, but then you'd also have the London, sorry, I almost said London Transport staff there, didn't I? The Metro staff, who would have their own Metro system with specific Metro apps to support them, and then you'd have the emergency services, the emergency services network, or sharing the same infrastructure, but having completely different applications on there. And the beautiful thing about running your own network is that you can then run applications on the edge. The sort of thing we're talking about here are location-based stuff which can track the unique flow of individuals as they flow through the system. So, for example, if there's a bit of a delay somewhere, lots of people getting down on the platform, you can actually slow down the escalators to stop overcrowding, or even stop the escalators for public safety. You can do security tracking. So normally, a passenger will go the quickest route from A to B. But if you can see where people are going, if you've got people who are meandering around and going in very strange routes, then they're probably not a normal commuter. And so you can then point fingers and investigate. You can give directions to travelers on the fly, because you can see where they're going. Personalised adverts is an interesting one. You've got a guy who goes down into the underground. This is, in fact, this scenario is pre-GDPR, isn't it? But anyway, if you know who he is, you know that you've got 30 seconds before the train arrives, and you know who he is. You can feed him on the wall opposite him, on a big screen, a big personalised advert just for him. You know, happy birthday, love your wife. Thank you, 100 quid. 30 seconds, it's brilliant. Okay, that's the Metro one. Here's another one that we've been looking at, high altitude pseudo satellites. This is all about putting cellular communications into places where there's none. And in particular, the scenario we're looking at is South Sudan, where there's been a bit of civil war, lots of refugees, most of them in northern Uganda. And the problem is, the Ugandans would be very happy if they went home, but they're not going to go home unless they know it's safe. So one way we can convince them to go home is to give them comms. And so they can phone home. Is it safe to go home? Yes, it's beautiful here. And so off they trot. The way we do this will be with solar-powered drones, state-of-the-art solar, and we'll just show you some pictures later. We put our small cells like this on the solar-powered drone. It flies about 55,000 feet. That's about 18 kilometers up, which is quite high. It's above air traffic control, above the weather as well. But it's low enough for the link budget to work quite happily with cheap and cheerful Chinese-made phones. And because the thing's moving quite slowly, you don't have to deal with that nasty Doppler shift that you have to deal with low Earth orbit satellites. Okay. And they're what, 180 to 200 kilometers high and fast moving. So from an engineering point of view, low Earth orbit satellites are tricky, but slow moving solar powered drone is a piece of cake. It's easy because it's lower and slower. And here are some examples of off-the-shelf projects. Project Arkila in Yeovil, bought by Facebook. The lady from Facebook's not here, but Facebook bought that. Enormous aircraft, the Arkila ones. It's 1.5 times the wingspan of a Boeing 737. Then there's Zephyr, so that's Airbus Industries based in Farnborough. Not quite so big. And then Sunfleet Communications Networks. This one's what have we done? This is, there's a bit of video. This one's Arkila. Dare we try a bit of video? Is this going to work? There we go. So Arkila is a Yeovil one bought by Facebook. Yeah, it's very, very, he's saying it's very big and bold. And so the uplink is laser. So uplink, downlink, and inter-platform link is laser communications on this one. This is where he says, yeah, that's what it looks like. It's kind of enormous. Launching it is quite interesting. I think they actually launched the real thing on a trailer that they pull behind a pickup truck. Recovery is quite interesting. When it comes down, it has airbags on the bottom, and they do a controlled stall about 4 feet off the ground and dump it on the airbags. It's Kevlar construction, using lithium sulfur batteries, so more power, less weight, and the solar cells on the outside are super thin. It's about like a toffee paper wrapper. Anyway, all British technology, but bought by Facebook. And this is saying how it works. Anyway, enough of that. Can I stop that? Can you stop? That's Project Arkila. I've broken it now. I can't stop it. I can't stop it. Oh, yes, there we go. I need to make it big. So, that's something we're looking at. I've broken it. And the beautiful thing about this particular project is the funding will come from the Department for International Development. So it's UK overseas aid money, but spent on UK companies like us to then deliver the benefit to South Sudan. So everybody wins. The government loves that. This is Zephyr. This is a smaller one. So this one is launched by 2 people. They run down the runway and throw it. But it is still quite a large aircraft. This one is bigger, obviously. And this one is now doing things like maritime reconnaissance. The great thing about these things is they can stay up for weeks, months. The target for Aquila is actually 3 to 4 years without coming down. You put it up and it just stays up there going round and round and round. Cheaper than a satellite, much cheaper. Anyway, that's Zephyr. And then this is the American one. The American one's quite interesting because they fly not one aircraft, but constellations of them, like ducks flying. And because they're spread out, you can then use the individual platforms to do active beam forming. So you actually form beams to beam in people down on the ground, and if there's interference, you null it out. The other advantage of using a constellation is that if one goes a bit wonky, they drop it out of formation and put up another one, and so it doesn't take down the whole lot if you have a problem. So that's the American one, headquartered in New York State, but flying out of Boulder, Colorado. And, whoa, this is where we go into the question and answer session. So, Evan, are you mic'd up?
Yeah.
Would you like to get a microphone? Sure. So this is where we're going to go slightly interactive. Andy, have you got a microphone?
I have.
Good. Come up here. Because I'm sure that some of the rubbish that we've been talking about has probably stirred something in your grey matter, and you want to ask the odd question. We'll probably do about, how long have we got? 10, 15 minutes of interactive questions. So come on, guys, come on.
Are we going up?
Yeah, we've got a little
Do we
panel.
come and give you a cuddle, do we?
So
hug.
can I introduce, this is, for those who don't know him, this is the indomitable Mr. Andy Smith, with 3 Fs, who is responsible for big lumps of the back end. So he's responsible for my back end. Evan McGee, for those of you who don't know, was CTO of
Ring Plus.
Ring Plus,
which was an MVNO in the US.
A very, very ambitious, very technically bold, if I say.
Oh, well, thank you.
MVNO, which was based on Sprint.
It was based on Sprint, that's right.
And had some extremely clever stuff in there.
Thank you.
But came to an untimely demise.
It did, sadly, you know.
Tell us about that, because that's...
Well, you know, businesses fail sometimes. No, we were an MVNO in Sprint for, gosh, 4 years, 5 years. We built the entire system ourselves, so we were just a standard MVNO. But we built all of these sort of OSS and PSS systems and billing and everything you could possibly use to run a cellular company outside of the actual infrastructure, like the back-end networking infrastructure ourselves. We used Asterisk, we used FreeSWITCH, we used Kamailio, we used all the bits and pieces. Everything was run on Rails. There was all kinds of, you know, little bits and pieces of Elixir and all kinds of stuff. And we did some really amazing things. In 2013, we did the first, I think, like in-call translation. We were using some of the unpublished Google APIs to, you know, beam audio at it and get back the translation stuff. And we could inject those directly into the audio calls using Asterisk at the time. And we switched to FreeSWITCH to do that even more robustly and kept doing a bunch more sort of innovative technology stuff like that. And eventually, in February of last year, we just got into a bit of a tiff with Sprint Corporate. And you can Google it and read all about what happened. And we ended up selling off the subscribers to Ting Wireless in Canada. And yeah, that sort of just kind of wrapped up that phase of running a wireless company for now. But from the Phoenix, you know, from the ashes rises a Phoenix, and the new company I'm working for is going to utilize many of these same ideas and same sort of, you know, methodologies to build a brand new company.
But you're not talking about that at the moment.
I'm not talking about that right now. This is not, we're not talking about that. I'm talking about whatever James wants to talk about.
Well, indeed. Well, the reason that Evan's up here is because he's gone through all of the pain of doing the mobile stuff,
yes,
and then had even more pain when the MNO daggered you.
Yeah, it turns out they have quite a lot of power, right? You are reliant on them for everything from, you know, billing to minute rating to everything else. And the more you give them, the more they can just, you know.
Well, this is where we go
around.
to the loaded question. And by the way, Martin, can we have Callum back again? Because I'm going to ask him a question, because I'm doing a little bit of interviewing stuff here.
I'll get out your head, Callum.
So the question...
Hey, Cam.
Yeah, hello, Callum. Fancy. You've got big head, haven't you? Yeah, so the question I want to ask you, Evan, is if you had all your own radio access network and your own evolved packet core, would that have made a difference?
I mean...
And that's an interesting question.
You speak of dreams and things I would have loved. Oh yeah, if we could have had that, it would have made... I mean, having that level of, you know, agnostic control of your own network and not being reliant upon MNO to do that transport could have let us do any number of things. Federation with other small MVNOs around the world. We could have done, you know, unique billing systems, unique billing models to help out consumers. Ring Plus's whole idea of the company was based on the idea that we were going to offer super low rates in exchange for when you made an outbound phone call, we replaced the dial tone with advertising and news and music. And that was going to subsidize the actual phone calls themselves. And that required a large amount of scale.
Brilliant. You just fed me the ball. Brilliant. Yeah. So one of the things that we're looking to do is to implement something which is quite common in the US, but not so common in Europe. And that's something called mutual forgiveness settlement. Mm-hmm. So one of the issues is that when you've got traffic going one way and traffic going the other way, raising invoices is expensive. So why don't you just net them off against each other? And as long as the traffic is roughly in balance, you just don't raise the invoice and you save the money. And the great thing about not sending each other invoices is that if you don't send invoices, there are no taxes either. Yeah, everybody wins apart from the government.
Yeah, taxes are a big part of it.
So it's a wonderful American invention. But the great thing about if you're a PNO or PNE, you can actually do some really quite clever things with balancing traffic. So everything becomes cost neutral. And everybody's happy. And even the MNOs are happy because they get coverage for their customers when they roam onto the private network.
That's right. Yeah. And they would love that.
So everybody wins.
That's it. They would love it. The only question with the MNOs in the US right now is that they are, you know, they are, well, two of them right now are obsessed with merging, right, to combat the other two. And so they are very risk averse. Right?
Yeah, and risk averse doesn't sit well with innovation, does it?
No, it really does not.
No.
They, you know, so it is a tough sell to come to them and say, hey, we have this brand new kind of technology and a very cool idea way to move this forward, and say, hey, can we work with you on this before we make any money on it? Now, once you're actually making money on something, or you have an idea that can make money quickly, then they are very excited to talk to you.
Right. Well, you fed me a ball. I'll feed one back to you. So, applications that you can sit upon the network. What do you think?
Well, I think there's all kinds of stuff. I mean, this is what we tried to convince Sprint of for years, was that if you built applications in the cellular network, you could access everyone on every device without having to deal with any kind of, you know, platform issues or any number of other problems. So I think that there's an immense amount of value in there. Everything from simple call recording on phones all the way up through, you know, in-call assistance and translation and...
And the key to success is to be in the signaling path all the time.
Exactly.
So if you can be in the signaling path, you have power. You can do amazing things.
Absolutely.
Okay, that's brilliant. So talking about being in the signaling path, segue to Mr. Smith.
We are very much in the signaling path of absolutely everything. And it's mainly diameter. And what we're really talking about is attribute value pairs. We're just talking about sending little values around within the network. And it's so powerful. You can do so much with it.
Yeah, and there are examples. So give an example of something you can do.
Well,
how about location?
We can do location. We can. I mean, 4G and in fact mobile networks in general, have to work. The phone has to be, its location has to be known to the operator. If they're going to provide you service, they have to know where you are. Now there are clearly personal data problems here, but with that location information, you can do so many things. And you can tell how fast people are moving in one particular way. In James's case, let's say a car comes speeding into the village, right? He attaches to your network. You know exactly how fast he's gone through your village, what his average speed is anyway.
And if he goes too fast?
Well, what do you do?
Well, we send him an SMS message. Yeah.
Exactly. Yeah, exactly.
And if he does it lots and lots of times, we can escalate, can't we?
You could, although I'm not sure that that's the correct use of data. But
yeah, anyway, so all kinds of things you can do. So, yeah, the key to success is to be in the signalling path.
It is very much. And as you would know, with anything that we do with VoIP, if you're in the signalling path, you've got a much better chance of actually doing anything at all, rather than just passing traffic.
In fact, do you want to talk about the types, don't go into specifics, but the types of signalling that we're putting in at the moment?
Okay. Well, within certainly a 4G network, everything runs with diameter, as we've said. So diameter is a bunch of different messages of different message types, but essentially it's just different attribute and value pairs. So they need to go to various places. So you've got proxies that redirect within the network. You've got edge agents that move things within and out of the network, and just like firewalls, really. And they push data where it needs to be. I'm not going to say any more than that.
Okay. And an example, SMS messaging.
Okay. Yeah. Well, SMS messaging. I mean, lots of people in here have used SFTP, SMS messaging, the traditional messaging you use on your phone. It's quite expensive, relatively.
It costs about 2 cents per.
At a wholesale
SMS.
rate, it's still two cents a message locally, even within the US or something like that. If you do it via diameter, doesn't touch SS7, doesn't go off the internet. It goes straight between two parts of the IMS network, effectively, between operators, and then to your phone. Costs them nothing. So you can do it really, really cheaply. The only problem with that is that you have to be an operator to be able to do it. So they're still going to be charging people 2 cents a message. So really, you want to be an operator so you can push it.
Okay, right, I think we're coming into question time. Have we got the hand mic?
My question was just, can we start Q&A?
Yeah. Let's
okay.
do it. Yeah, well, that was just a little intro, but yeah, we're going to... Yes.
I've had a little go with mobile number ranges myself, and not had very much success with the other operators. So how are you guys getting on with the other operators now that you know, you're a full-blown operator? Are they playing ball?
That's one for you, Callum.
So yeah, the good thing for us is that we're deploying the network on a money basis. So the operators are quite happy to get that extra coverage for themselves.
Yeah, the key to success here is to give them something they want back, and at the moment they're under the cosh from Ofcom, the regulator, to achieve coverage. And certain operators, in particular O2, some way away from what they're supposed to have done.
Okay,
As far as the numbering is concerned, we have secured the own numbering range from the regulator.
Yeah. And I think you're talking about the difficulty in getting the other mobile network operators to fill the number ranges and route.
Exactly, yeah.
So the key to it is the IR21,
Okay.
which you can't get at unless you're a member, or you can get to another member who will do it for you.
Okay, and last question. You're deploying 70 of those boxes. I would imagine if you've got pretty bad coverage for you know, mobiles, surely the internet's not that great there either. So how are you going to get feeds to all of those 70 boxes instead of 5? Fiber.
We're using the community project is set up in almost exactly the same way as B4RN, Broadband for the Rural North. In fact, we copied their organisation. And the difference is, rather than put a fibre into every single house, Chalk Mobile puts a fibre into 1 in 15, 1 in 20, and then uses 4G to do the rest of it. And it's double whammy because it does both mobile, MONeH, and fixed wireless broadband. So it makes more money. So it's cheaper, makes more money than barn. Okay, another question.
Hi, yeah, I've got a couple of quick questions. Do you want them together or separately?
Yeah, go for it.
So, first one, you mentioned the E1000.
Yeah.
And you mentioned your white 3D printed box.
Yes.
Can you tell us more about the 3D printed box and the cost of that?
I can't commercially at the moment. It will be a commercial product, but it's definitely pre-release and it's not advertised. I mean, we've got it because we've got a back end to plug it into.
Right. I wasn't sure if it's something you'd hack together with a Raspberry Pi that people could recreate, or whether it's something you're making as a product. But
it's not our product, but it's one of our partners' products.
Okay.
So so it will be sold, I think, with or marketed with our back-end service because the two sit together nicely, we think.
Okay, and my last question. You get many devices now with Wi-Fi, Zigbee, Z-Wave, or Z-Wave, whatever you want to call it, and all of these different devices accessing networks. If LTE and narrowband IoT are going to be the thing to replace Wi-Fi, is there some alliance where the hardware manufacturers are going to get together and start to standardise on this?
For small cells, is this, or?
Well, for any applications.
Well, there are a number of trade bodies. The small cell one is called the Small Cell Forum, who run things like the Small Cell World Summit.
I just wondered whether in sort of 2 or 3 years' time we're going to go out and buy laptops rather than having Wi-Fi as standard, they're going to have LTE as standard.
I think you'll probably end up with a software-defined radio that does both. What do you reckon?
Yeah, I think that I know the U.S. is trending towards that way. I wouldn't be surprised if Apple were to include LTE in a future release of one of their laptops. I think that would actually tie more into as their carrier integration gets deeper. That would be a pretty natural play for them, particularly if they could put up some way to then monetize that on their side.
Yeah. Looking into my crystal ball, what I would expect is that instead of having these dedicated boxes like the E1000, which just does one thing, you just have a generic software-defined radio that does any waveform, and you just use the appropriate waveform that corresponds with what you're doing at the time.
And a lot of it comes down to the business relationships. I remember, the reason why FaceTime worked and many things didn't originally is that Apple put FaceTime servers in the network cores of all of these different operators. So it never actually hit the public internet, which is why FaceTime operated and nothing else did over the internet back for a long time. So those kind of similar business relationships are still continuing. I wouldn't be surprised if they struck one of those and then integrated a software-defined radio and they made it all work and just magically appears one day.
Great. Okay, Corey, that microphone keeps on switching off. Yes, go ahead.
Okay, so say I'm sold with your original sales pitch that you did at the beginning of the presentation. So I rip out all the Wi-Fi in my network and I put in
well, you don't have to rip out your Wi-Fi. You can leave it there. It's not hurting anyone.
I put a 4G base station on the base 40, which is unlicensed. I forget which one was unlicensed.
The multi-fire, the 5 gig stuff.
And now, so then I have nice high-speed data walking around my house. But then how do I go through the step?
Well, the important thing is it's not just you who has coverage. When the postman comes up to your house, he has coverage. When the delivery man, DPD man comes, he has coverage too. That's the important bit.
Now that bit only works if you're going via this PMNO system, which is all the aforementioned legal regulatory requirements.
Yeah.
Okay. And then you don't need a special SIM card there. You're using your...
the people who roam onto your network just use their own operator SIM. And the great thing about it is you want to encourage as much traffic as you can to come and use your cell, because if they use your cell, then you can use their network for free, because, the mutual forgiveness. So, knowing you like I know you, Corey, you'll be sitting at home with the cheapest possible data plan that you can get, anywhere, just burning minutes through your own private network so you get you can access any other network at any other time.
But I suppose you don't have the legal compliance in Belgium yet.
No, is the answer. But I thought about that.
And
but Belgium is...
And the second question is, you mentioned about these super amazing SIM cards. They have a SIM socket. How do we access it?
They currently do not have SIM socket, but it's on the roadmap. They just have the OTA function that I mentioned. And multi-IMSI.
Okay, so the current... only
so
way
I think your question is, what can I do with it today?
Yes, pretty much.
Well, you can put your own IMSIs, your own crypto, and a few other bits and pieces. Do you remember what you can do with it?
A full profile. You have to look it up.
Yeah. You can do lots of stuff you can do with it.
All right, thanks.
That's a really crappy answer. Another one at the front. Come on. No, here it comes.
So you talk.
Mix minus.
Stand up. Come back. Far enough.
Yeah.
So you talked about your backend service, and I see it's Research, I think, on your name badge.
Yeah.
And then there's MONeH, and then there's Signal Wire. You really need a microphone.
Yes, because otherwise people can't hear on the recording.
Go forward. Okay. Yeah.
It's confusing, isn't it?
Just come on up.
To the stage.
Just come on up.
Okay, cool. So you talked. Sorry, Callum. You talked about so who's who and what names are these different components? Which company is offering which service, and where do we go for more information?
Telet are offering a multi-operator neutral host back-end service, which will then allow anybody who wants to build their own private network. And Chalk Mobile is an example. Chalk Mobile is a community interest company based in Southwest Wiltshire. But they will own all the radios, which will be paid for by the government. Thank you, government. But then Telet Research will provide the service. I've got to be very careful. I'm not a director of Chalk Mobile, even though I was a founder, because my company are providing the service to, and it's a conflict of interest, if that makes sense. So if you want to set up your own sort of private operator, then you can do so, but we'll provide you with a service. I think that answers the question.
The easy way to look at this is to refer to Telet as the network operator and Chalk Mobile as the service provider running on Telet Research network.
Yes. Okay, another question.
All right, very, very simple one. What's the ballpark figure of doing it then?
Cost.
Yeah.
For what?
To set us up as a private network operator?
Well, the budget for Chalk Mobile, which is between 50 and 70 cells, and you might say why 50 to 70? It's because that's the size, the number of cells that we've got to do the first one, do with the first one in order to have enough traffic to make it viable. So the cost of that is about 1.5 million, all up. And 90% of that will come from central government. Bulk of it from DCMS, but a chunk will come from BEIS through the local enterprise partnership, and about 10% is raised locally.
But are you then saying that we can then roll off the back of that, if that makes sense?
Absolutely, yep.
Okay, so the question from me really is what's the cost of riding off the back of that?
If you're looking to do a commercial service in the UK, you can't. Not this way. This is only, it has to work on, as we stand at the moment, in geographic locations where we can get spectrum.
Yeah,
spots.
Let me explain that a little bit further. Chalk Mobile is rural not spots. Why did we choose rural not spots? Answer, because it gets us 800 megahertz spectrum, a real proper license. And in order to become a full member of the GSMA, you've got to rock up with a proper license for proper spectrum and put that on the table, because if you turn up with a shared license for DEC-GAR band for it, they'll go, ha ha ha, that's not good enough, go away. So as a starter for 10, we had to have a proper license. That's why we went for rural. And the secondary use on a non-interference basis license is a very clever way of doing it. The great thing about it is we think we're going to get it from Ofcom for no money, correct, Callum?
Yeah, correct.
Yeah, so that gives us and yet another question at the front. Does that answer your question?
Sort of. I'm not really sure how it's going to help us move forward. That was the only...
Okay.
Well,
maybe talk for later.
I think you're probably quite interested in urban in-building, aren't you? Yeah. The spectrum for that will be deck-guard band, top end of 1800, and multi-fire as soon as the handsets catch up. So the first multi-fire cell was demonstrated in Barcelona this year at Mobile World Congress. Next year there'll be a whole load more, and we'll see the first raft of handsets that support it. The chipsets support it now. So Qualcomm Snapdragon 845, which you get in high-end handsets, will support every band up to 6 gigs. So in theory, it will do multi-fire. It's just that the manufacturers haven't made the phones yet, mainly because the bulk of the handsets are bought by the MNOs, who are not particularly interested in multi-fire, it has to be said. Can't think why.
Unfortunately, we are out of time for more questions, James.
Oh, thank goodness. So just one more.
Ask it after, because we've all got to drop off our bags before dinner and everything so that we can go to the pub. So thank you very much, James.
Priorities.
Thank you, Gil. Right.
That wasn't so bad.
That wasn't so bad, was it?
So, yeah.
Right.